Good morning, Science 20s. Our lesson today is going to be on momentum. Well, I'm going to start by asking us a couple questions. If I was to throw at you a frisbee or a barbell, and I was to throw it at your head at the exact same speed, which one would you like for me to throw at your head? And then the follow-up question for that would be why? So I think everybody in the room would probably choose the frisbee. But the question would be, why would you rather, Mr. Kemp, throw the frisbee at your head than the barbell? And yes, frisbee's going to hurt less, but why does it hurt less? Okay, I think we'd all agree something to do with mass. Frisbee has way less mass, way less weight than a barbell. Okay, so I'm going to give you another scenario. Again, I'm going to throw something at your head. So if I have this wonderful number 93 football player here, and I have him plow you down. Again, I like this because you're going to get hit. And you have two choices. He can plow you down at 45 kilometers per hour, or he can plow you down at 20 kilometers per hour. Which speed would you rather him hit you with? And then the follow-up question is, why? And again, I would think most of us would take 20 kilometers per hour because he's going to approach with less speed, which means he's going to probably hit less hard. Well, in both of these scenarios, both the frisbee and the barbell or the football player, both of these scenarios had something to do with momentum. Momentum is the product. So, product in math means multiplying. So, the product of an object's mass and velocity. So, when you multiply an object's mass in kilograms by their velocity in meters per second, you get momentum. So, if we think about the barbell frisbee scenario, I said I was going to throw at you the frisbee and the barbell at the same velocity. So this number is the same in both scenarios. The reason we want the frisbee to be thrown at us is a frisbee has less mass. So when you multiply it, you have less momentum hitting you in the head. Again, now let's look at the football player. In the example of the football player, we use the same football player, so his mass does not change. What changed was he ran at you at a fast velocity, or he ran at you at a slower velocity. So when we multiplied together, the slower velocity actually gave him less momentum. So today's lesson is going to be all about this: mass, velocity, momentum. These are the units we're going to use. So your mass has to be in kilograms. Your velocity has to be in meters per second. Again, if I give it to you in kilometers per hour, you know to divide by 3.6 to get it to meters per second. So let's do an example on here, please. So determine the momentum of a vehicle. So we are going to find momentum with a mass of 2,100 kilograms. Now, we know we like this unit already. We like kilograms. That was in the question. And it is going to be moving with a velocity of 22 meters per second east. It tells us in the question, assume east is positive. So we can say positive 22 meters per second. Now, again, I want to point out this formula. This formula is actually in your data booklet on page 2. Again, if it was me, I would take a highlighter and I'd be highlighting the formulas as we learn them. If I take a look on here on page 2, I would have highlighted already 1, 2, 3, 4, 5. This will be the 6th formula I would have highlighted on this page. So kilograms, meters per second, I like it, so I'm going to use my formula. Momentum equals mass times velocity. Again, I'd like to point out momentum is a vector quantity, so it will come with a direction when we're done. So I'm going to take my mass of 2,100 kilograms. I'm going to multiply it by my velocity of positive 22 meters per second. And my momentum is going to come out to be a very big number, 46,200 kilograms dot meters per second. And again, it's positive, so we're going to put a positive here. But also remember what that positive means. That means my answer is 46,200 kilogram meters per second east is our momentum. Again, if you would like, we could certainly put this into scientific notation. 4.62 times 10 to the 1234 kilograms meters per second east. I would take any of these three answers. So what I want you to see is this formula is actually really easy. Okay, well, let's try then another question. So in this question, why don't you copy it down, pause the video, try it for yourself, get as far as you can, and then unpause the video if you need to check your work or you needed to figure out what to do next. So the total momentum of a motorcycle and rider is, so we know the momentum, 7.20 times 10 to the 3 kilograms dot meters per second. It says south, so I'm going to put a negative sign. If the combined mass of the rider and the motorcycle is 250 kilograms, determine the velocity of the motorcycle and rider. So kilograms, meters per, I like my unit. So my original formula in my data booklet is momentum equals mass times velocity. In this question, we are trying to find velocity, so we would like it by itself. So when I move mass across the equal sign, it's going to go from upstairs downstairs. So my formula is going to be velocity equals momentum over mass. So my momentum is negative 7.20 times 10 to the 3 kilograms dot meters per second over 250 kilograms. So typing this in, negative 7.20 times 10 to the 3 exponent, enter, divided by 250. I get a negative value, so negative 28.8 meters per second, or I could write this as 28.8 meters per second. And remember, my negative actually represents the direction of south. Excuse me. So let's try another question. An airplane. So our second last question here. An airplane has momentum. And again, why don't you copy the question, go as far as you can, then check your work. So it has a momentum, 8.3 times 10 to the 7 kilograms meters per second. And this is going to be north. So let's make that positive. It's flying with a velocity of 990 kilometers per hour. And again, that's north, so that's positive. I have to change this to meters per second, so I'm going to divide by 3.6. So 990 divided by 3.6 is 275, so that's going to be positive again. And we are trying to find the mass. So meters per second, kilograms, meters per second, I like it. Momentum equals mass times velocity. We are solving for mass. So we are going to move velocity to the denominator. So mass equals momentum over velocity. So positive 8.3 times 10 to the 7 kilogram meter per second over positive 275 meters per second. 8.3 times 10 to the raised 7, enter, divided by 275, enter. And my answer is going to be very large, so I'm going to put it in scientific notation. 3.0 times 10 to the 1, 2, 3, 4, 5. and this is in kilograms. Remember, there's no direction because this is a mass. My units canceled off. Well, let's try one more, and then I feel comfortable letting you go off and do a worksheet. So we have a scenario here, a rock and a person in this cartoon, and it says on the right, but it's on the left, both have the same momentum. So let's make up a momentum for these guys then, so we can say they have the same. So because they're pretty big, let's give them both the momentum of a positive 100 kilogram meters per second. He's also got a momentum. Okay. Will the rock hit the person? So ideally, we want to find out the velocity of the rock and the velocity of the person. If the speed or the velocity of the rock is more than the speed of the person, then the rock will eventually overtake the person. So yes, it'll hit them. If the rock's velocity is less than then the person runs faster and will never get hit by the boulder. Looking at the picture, I think we can all agree the mass of the boulder is going to be significantly more than the mass of the person. However, what I want to do is I'm going to pick some easy numbers. So let's put the person's mass at, I don't know, 50 kilograms. And let's put the rock's mass at, again, something a little easier, 200 kilograms. So looking at the formula, if we are trying to find velocity, right, my formula is going to be velocity equals momentum over mass. So let's do this first for the person. So the momentum is the same in both scenarios, but the mass of the person is significantly less. So 100 divided by 50, the momentum of this person is positive 2 meters per second. Excuse me, the speed of this person is positive 2 meters per second. Now, let's do this question again, but this time let's do it for the boulder. So, same formula. The momentum is the same as the person, and it's positive. But the mass of this boulder is significantly more. So 100 divided by 200. Well, what we figured out was the person will be moving 4 times the speed as the boulder is going. So the question is, will the rock hit the person? No, never, because the person is running way faster than the rock is rolling down the hill. Therefore, the person is going to be safe and will not get hit by the rock.